welcome back. Today we will be looking at solving simultaneous equations. In front of us here we just have three things that we should have a good grasp of before we should be attempting to solve simultaneous equations. Those things are, we need to be able to recognize linear equations, and we have a video on that that we did previously. I would encourage you to look back on that video if you're unsure of anything got to do with recognizing linear equations, solving linear equations, or if you're unsure of what variables, constants and coefficients are, as they're going to be huge foundation blocks for our success in solving simultaneous equations. Now, if we think back to our linear equations and what they are, or how we might recognize them, well, one thing that we did establish in our last video was that if we were to go ahead and graph a linear equation that was given to us, and the key here is in its name, the shape it would take would be a line, okay, and we would graph it as a line segment. All right, so that's what we're expecting to see here. And when we think about just the word simultaneous from an English perspective, all that means is working with something at the same time, okay? So working with two things together in coordination with one another, in other words. All right. So here we have two linear equations. 2x plus y is equal to 2, and y is equal to 2x minus 4. All right. I have graphed the lines for these linear equations on our axes. Here we obviously have our y, and then horizontally we have our x-axis. So when we work with our simultaneous equations, and these are simultaneous equations in two variables, we will be moving on to three variables, and that's where things maybe get a little bit more confusing, but for now we're going to focus on this. When I look at them in two variables, what I'm really thinking about is just two lines, and where do they intersect with one another, okay? So we're on a 2D plane, and we're looking at where these guys meet each other. And we can see obviously from our graph here that it's going to be this red point where they cross over. But how do we find out what the coordinates of that are? All right. Well, one way we could do it is we could, bring this up to our x-axis and estimate what the x-coordinate is, and bring this across to our y-axis and estimate what our y-coordinate is. But that always leaves a little room for error, okay? Because we're only human, we might misread it. We might have our axes just a little off what they should be, and there could be those small mistakes. So if we wanted to achieve this in an algebraic manner, we have a way to do it, and it's just by combining these two guys, working with them using the rules of algebra we've seen so far and that we've come to know, and it should hopefully give us out our solution as to the coordinates of that red point there, the point where the black line segment and the green line segment intersect one another. So all I've done here is I've taken those two linear equations and I've just placed them onto their own sheet of paper, one on top of the other, because that's the easiest way to tackle these guys. So we can see obviously our top one there, which was represented by the black line, is 2x plus y is equal to 2, and the lower one, which represented the green line, is y is equal to 2x minus 4. So our first step here should be to get these two guys to look the same. Okay, we want them to look similar to one another. And at the moment they don't, because I have my two variables, my 2x and my y, on the left hand side of the equal sign, and then my constant on the right for my upper line. But then on my lower line I have my y variable on the left of the equal sign, but my x variable is on the right. So the first thing I need to do is I need to get that somehow across to the same side as the y, and the way that I do that is I subtract 2x from both sides. So now if I were to bring this down, my top line is going to stay the exact same, 2x plus y still equal to 2. Those two guys will cancel because I have a positive 2x and a negative 2x, and what that leaves me with is minus 2x plus y is equal to minus 4. Okay, so now they look far similar. We can see that we have our 2x over our minus 2x, and we have our y over our y, and then we just have our constants on the right hand side of the equal sign. And this one has actually worked out quite well for us. It's a pretty basic example. So now we need to look at combining these guys. And in this particular example, it's set up very nicely for us, because when we combine them, what our goal really is to somehow eliminate one of the variables being x or y. And in order for two things to eliminate each other or to be opposites, one of them should be a positive and one of them should be a negative. That makes sense, right? And we have that here with our x values. We have a plus 2x and a minus 2x. So if we were just to kind of push these two lines together using our rules of algebra, which are, you know, like with like, so our x variables with our x, our y with our y, constants with constants, what we would see is 2x take away 2x gives me 0. Y plus y is equal to 2y. Okay, and then we combine our minus 4 and our 2. Well, that would just leave us with minus 2. So now we have 2y is equal to minus 2. If we were to employ our rules of algebra that we've seen so far, we would know that in order just to make 2y 1y, we divide it by 2. 2 goes into 2y, just 1y times, and 2 goes into minus 2, minus 1. Okay, so that's a lot of the heavy lifting done there. I would encourage you to pause the video, try do it yourself, or perhaps just rewind it 30 seconds a minute and look through that again. So now we have y is equal to minus 1. What's the significance of that answer? What does that mean in the grand scheme of what we're trying to do here? Well, if you recall, what we're looking for are the coordinates of that point there. Okay? And we know that all points on our 2D plane, or on our x and y axis, come in the form x, y. And we have y is equal to minus 1, which makes sense if we think about our y-axis. It's, you know, below y is equal to 0, so it should be a negative number. That makes sense. But now we don't have our x-coordinate. And what we need to do is establish what is our x-coordinate and how do we find it. Well, hopefully what we recall from the last video on linear equations is that in order to find an output of a linear equation, if we have the value of one of the variables, the x or the y, if we sub it in, the solution that we get will be the value of the other variable. Okay, so now we know that y is equal to minus 1. And what we're going to do is take that y is equal to minus 1 and sub it into one of these equations. It doesn't matter which one, both of them will give us the same solution. So I'm going to do the top one and we'll have a look at that. Okay, so what that gives us then is 2x plus, now it's no longer y, it's just minus 1, is equal to 2. So then 2x minus 1 is equal to 2. Let's add 1 to both sides so we can get just the 2x on its own. So if I were to add 1 here, cancels, add 1 here, it becomes 3. So 2x is equal to 3, divide both sides by 2. 2 goes into 2x, just 1x times, and 2 goes into 3, 1.5 times. Alright, and what I would encourage you to do here now is to pause the video and put minus 1 in for y on our lower linear equation here, and we should see that we get x is equal to 1.5 as well. Now if we refer back to this, what that tells us is that our x coordinate is 1.5. So the point of intersection between our black line and our green line is actually 1.5 minus 1. And that's our problem solved. That's the solution to this. Obviously, the questions that we see will be slightly more complex. They will at times be worded a bit differently. But if we can remember those foundational blocks, those stepping stones in order to getting to our solution, they will come in useful every single time we answer one of these questions. So here we have two more linear equations. We're going to solve these as simultaneous equations. The only major difference here is that we won't be graphing them out. We will be checking our answer algebraically rather than having a look at a graph and seeing if we think it looks right. So again, we approach these guys in the exact same way. The first thing we want to make sure of is that they look the same. Okay, they look similar. So again, they do. We have 3x over 4x, so our x's are lined up. We have 2y over minus 5y, our y's are lined up, and then over on the right hand side of our equal sign, we have our constants. So now before we combine these, if we recall from our last example, we wanted to ensure that the coefficient, right, coefficient being the number before one of the variables, so the coefficient of either the x's or the coefficient of the y's were the same. Okay, I'm going to try and make the coefficient of the x's the same here, because it will give us the opportunity to see how we also change the signs. Alright, so if I think about a coefficient that could be before both of these x's, I would think about the lowest common multiple of 3 and 4. Okay, so what number do 3 and 4 both go into? The smallest one is going to be 12. Alright, so how do I make 3x 12x? Well, I multiply it by 4. Alright, and how do I make 4x 12x? Well, I multiply it by 3. So we kind of multiply them by each other nearly. Alright, now I can't just go ahead and multiply just my 3x by 4 or just my 4x by 3. I need to make sure that I'm doing everything fairly and I'm applying the rules equally to every element of this. And when I do that, what I'll see is I need to multiply, of course, my 3x by 4, which gives me my 12x. I'm going to multiply also my 2y by 4, which gives me 8y. And I'm going to multiply my 21 by 4, which will give me 84. Okay? And now we come down to my next line. Well, I have 3 times 4x, which gives me 12x. 3 times 4x. 3 times minus 5y gives me minus 15. Okay? And then we have 3 times 28, which will give me 84. Alright, so these things are looking a lot better for us here, and we can start to maybe combine and solve. Now, of course, we could have had the coefficient of the y be the same, and it would have made our lives a little bit easier, but there's a better learning opportunity here in terms of changing signs, and we'll see that in a moment. So now, just like our last question, we want to combine these two green lines with one another, but we would like, again, one of our variables to cancel. So at the moment, 12x and 12x, that's 24x. Okay, that's not going to work for me. It's not going to become 0. And 8y and minus 15y, that won't work either. So in order, again, for two things to combine and be equal to 0, what we need is for them to have typically opposite signs if we're thinking about addition and subtraction. So what I'm going to do here is I'm going to change the signs of one of my lines. It doesn't matter which one. I'm going to go for the bottom line here. And just like my multiplication, I need to change the sign of everything. We need to treat everybody fairly when it comes to changing our signs. And now we can combine. Well, 12x, take away 12x, well, that becomes 0. Okay. We have 8y plus 15y. Well, that gives me 23y, okay, and then we have an easy one here, 84 minus 84, well, that gives me 0. Alright, and 23y is equal to 0. In order to get 1y on its own, we multiply both sides, or sorry, divide both sides by 23. 23 goes into 23y 1y time, and 23 goes into 0 times. So we can see that y is equal to 0. So again, if we were to think back to the image of these two lines intersecting, we're looking for an x coordinate and a y coordinate. Well, we've just discovered that the y coordinate is 0. And now in order to find the corresponding x coordinate, we need to take that y coordinate and sub it back into one of our lines here. I'm going to take the top line, and what that gives me is 3x plus 2 times y. Well, we've said that y is 0, is equal to 21. 3x plus 2 times 0 is 0, is equal to 21. 3x is equal to 21. Now in order to just get x on its own, we're not too interested in what 3x is, we're just interested in x. We divide both sides by 3, by the coefficient. 3 goes into 3x just 1x times, or x times, and 3 goes into 21, of course, 7 times. So we can now say that the point where these two lines intersect with one another is the point 7, 0. And if we want to verify that, okay, first of all, if you want to verify that x is equal to 7, what I would encourage you to do is to take your y value of 0 and sub it into the lower line. But if we just wanted to double check ourselves, let's take those values of 7 and 0 and sub them both into one of the lines and see if it makes sense for us. Okay, well, we've said that, I'm going to take the lower line here, we've said that x is 7, so 4 times 7, that should be a minus. 5 times our y coordinate, well, we said that that was 0. And that should, if everything makes sense for us here and is correct, it should equal 28. Alright, so 4 times 7, well, that gives me 28. Minus 5 times 0 is just 0, is equal to 28. So is 28 plus 0 equal to 28? Yes, it is. Okay, and that is how we have verified our answer there. We do have the correct solution. We found it by following our steps, going through it logically, and then we've even double checked our answer, and we have verified that it is the correct answer. So again, with this question, we could have made our lives a little bit easier if we had of just worked to eliminate the 2y and the minus 5y, because their signs were already opposite to one another. We could have cut out this small step of changing the signs. Alright, and if we're again just to think about the logic of changing the signs, I know it sounds pretty basic to say, oh, just change the signs, but in mathematic terms, what we've actually done here is we've multiplied everything by minus 1. Okay, because 12x times minus 1, well, that becomes minus 12x. Minus 15y times minus 1, that would become plus 15y. And then 84 times minus 1 becomes minus 84. So I've oversimplified by saying just change the signs. There is logic behind it, there is reason. We're allowed to do it because it is multiplying by minus 1. But if it makes our life simpler just to think about it as changing all of the signs, we can stick with that. So hopefully following this video now, we feel more comfortable with approaching simultaneous equations. We're very much of the mindset that we have our logical steps that we need to carry through and we need to do, and we need to make sure that we do properly if we're going to get a correct solution. We're very much aware of what linear equations are, and that this is just dealing with two linear equations at the same time to see where they meet each other. Okay, and that probably sounds very straightforward. The more comfortable we get with these, the more straightforward they become. I might do another video just looking into a few more examples of these, working through them. I would encourage you to work through a few examples on your own. And of course there will be another video where we look at solving simultaneous equations with 3 variables. So that might take the form of 2x plus 3y plus 4z is equal to 18, and seeing how that works and how it's on a 3D plane. But for now we're just going to focus on this. We're going to review this and try and get a better grasp of it by using different examples. Be sure to check out the website, it's linked below for more notes. Personalized notes and services are available, so feel free just to have a look there and get in contact if there's a video you would like to see on a specific topic.